My name is Jesse. I am a Maze Guy, and this is Math with the Maze Guy. All right, so today's going to be a continuation of what I was talking about last time. There were a couple of math symbols that I didn't necessarily get to, and I feel are quite important to at least be introduced to them. The first ones that I wanted to talk about were going to be greater than or less than. Now, these two are basically going to show you in an equation, this side is going to be less than that side, or vice versa. This side is going to be greater than that side. So as I'm speaking this, as I'm telling you some of these explanations, realize that we're reading things from left to right, always left to right, but in math, as I was mentioning before, we can kind of move things around sometimes. When it's multiplication and addition, we can. That's called the commutative property. Those are vocabulary words that I didn't necessarily focus on, but you need to know what they do and how they behave, especially in equations. But greater than or less than is basically going to tell you 3 is greater than 2, right? We know that for a fact. If we're counting 1, 2, 3, 3 is more than 2. We know that. If I said 3 is less than 2, we know that's not true, right? No, that is not true. The opening is going to point to the bigger number. So, and again, that's where I come with the words. 3 greater than 2, 3 is less than 2. This one's wrong. But if I added an x here and said, well, there's a number that we multiply with that makes this true. Well, we can try x equals 1. 2 times 1 is 2. No, that doesn't work. How about 2? 2 times 2 is 4. Then yes, 3 is less than 4. So when x is 2, 3 is less than 4. Or 3 is less than this particular side of the equation. If we want to know what number, sometimes if we see that line below it, it's going to be equal then. Less than or equal to. It could be equal or it has to be less. So think about this. We'll go over some more examples a little bit later, but I just kind of want to introduce you to what they are. Greater than, less than, or equal to. We can put a line on either one of these. It's going to say greater than or equal to, less than or equal to. Okay? Another one I wanted to talk about was that one. The absolute value. Absolute value is a little deeper than what I'm going to go into right now because there's a function, there's things that define it, blah, blah, blah. But at this point, you should just be a little bit more aware of anything that's negative in there is going to be positive. So if we have the absolute value of negative 2, that's going to be 2. Absolute value of negative x, that's going to be x. Same thing, absolute value of negative xy, that's going to be xy. Okay? So just realize that absolute value is something to look for, but it definitely gets a little bit more than what I'm just going over here. But we can go over some examples later on in some of the other shows that I'd like to do. Now, another very important one is the squiggly lines. The squiggly lines means approximately, or there's another one that I'm not necessarily remembering right off the bat. Oh, congruent. These are congruent. It's not necessarily equal, but they are the same, or it can be approximately this. So instead of using an equal sign, sometimes we use a squiggly line to say, well, this is the same, or it's congruent, or it's approximately. Okay? One very important sign is the percent sign. Percent is anything, we're talking about fractions really. The interesting thing is when you say percent, the word actually tells you. It's per 100. So if we're talking about 10%, it's 10 over 100. 10 per 100. So always think about that. If you're not able to figure out what it is, they're telling you, well, what's 14% of some particular number? You're saying 14 of 100 is equal to sum of whatever number you're talking about, 14% of 23. And then you figure out what the x is. So very important is percent, and again, more examples will come later when I start talking a little bit more about that. So I'm going to go ahead and erase this and go into a couple more symbols. All right, so now I want to go into some of the symbols that really excited me as a child. I remember being a young child and thinking, oh, I really like this. It looks so confusing, but it's not necessarily that confusing. It's just a language, and it's just something that you kind of have to look at and figure it out. But yeah, in that sense, one of the main ones that kind of intrigued me was the square root symbol. Square root is kind of the opposite of, so I'm just going to put little lines here. That doesn't necessarily mean anything. It's just going to be opposites of x squared. Anything that's squared. So if we're looking for the square root of 4, we're looking for a number that is multiplied by itself times 2, or times itself, not times 2, times itself, that gets us 4. And yes, that's going to be 2. So if we're looking for the square root of 25, is there a number that multiplies by itself to get you 25? Yes, it's 5. So what if we're looking for like the square root of 10? Is there a number that multiplied by itself gets you 10? Well, we can easily look for that. If we look at 3 times 3, that's 9. 4 times 4 is 16. So 10 is somewhere in between there. So no, it does not. So the square root of 10 is going to be approximately, there's that little squiggly line, 3 point something. We don't know what those last numbers are, but 3 point blah, blah, blah. That's the approximate number. We don't know. The exact number is going to be some long decimal number that we're not going to necessarily write out. So that's what square root is. We're looking for some number that multiplied by itself will get you that number down there. Now the weird thing is sometimes I used to see a little number in there. So I used to see like a 3 outside that square root. 3. So at this point what we're doing is we're looking for a number that multiplied by itself 3 times gets you this particular number. So the cubed root of 8 is going to be 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 2 is going to be the cubed root of 8. So just keep that in mind when we're dealing with square roots or roots is basically going to be it. Square root is just nothing out there. Cubed root, fourth root is going to look like that, and so on. So that's what this symbol means. Now, when I was a kid, I used to wonder what this meant. I was like, well, why in the world do they have a fraction as an exponent? Well, the proof of it, and mathematicians are always going to say, well, prove it to me. Show me all the fundamentals, and then we're going to come up to that particular notion on why this actually means the third root of x squared. So it's kind of interesting. The denominator is going to go into your square root, and the numerator is going to be outside. It's the whatever root you're looking for. Just trust me on it because, again, a lot of it goes a little deep. But when you see something like this, this is what it means. And we tell you that this is this because in the long run, you see some weird long equation and you're like, well, what is the third root? Well, we don't know. Or what is the square root of 10? Or we just don't know. What's the square root of, well, I'm not going to get a little bit too much into that, but that's where we come up with fractions in your exponents. Now, there's two other symbols that I kind of wanted to go over. Well, a couple more that I'm going to go over, but these next symbols that I'm going to write up here are going to be a little deep. They go further into your studies, and you may not see them if you're going to stop after college algebra or whatnot, but they're pretty helpful and they're pretty interesting to learn. So give me a moment. All right, so this particular symbol is interesting because it looks weird. It looks hard, but it's not necessarily that hard. Summation. That just means you're going to add summation. Sum means add. You're going to add certain numbers to each other. Now, when you see this, you're usually going to see a little letter equals 1 or 2 or 3 to some other kind of letter up here. So let's pick 5 and N. So this is very, very simple. You eventually might see something really long here, but all you're going to do is plug in 1, 2, 3, 4, 5, 1 all the way up to the number 5 wherever you see that letter. So in this case, it's just an N. So we're going to go 1 plus 2 plus 3 plus 4 plus 5. So that's 9, 12, 14. That's going to be 15. The answer to this looking thing is 15. Now there's a similar situation when it comes to multiplication. That one looks like that. That is the pi symbol. Pi is usually going to be written like this with a squiggly line over it, and that's going to be another approximate 3.1, oops, writing a little too hard there, 3.14159 blah, 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 blah. That one goes on forever and ever. But that's approximately. Now, when we see just a straight line, we're talking about multiplication. So in this case, we're going to say x equals 1 to maybe 4 of x. That equals, again, 1 all the way up to 4. So it's 1 times 2 times 3 times 4. 4 times 3 is 12. Sorry. Oh, how am I so horrible there? Anyway, you're getting hopefully you're getting this particular concept as far as what this symbol means and that symbol. It's just a little added thing that I kind of wanted to throw into the show. Just like this one, that means for every, it's later on, you're going to see for every x there exists blah, blah, blah. And that means there exists. So for every, there exists. I'm going to erase this and I'm going to show you a pretty cool looking example using one of these. All right, so this is what I saw once on a Facebook post talking about, figure this out, we'll give you whatever. I think it was some fast food restaurant. But I saw this and I thought, that looks hard, but it's not necessarily hard. So let's kind of break it down and figure out what we're actually going to do here. What I just mentioned is this is a summation sign. So we know we're going from 1 to 461. Sounds like a lot, but trust me, it breaks down to a lot easier than that. We're going to look at this particular thing first. I, there's an I here, so this is going to change. The I is always going to be 1 and then 2 and then 3 and then 4 and so on. So let's leave that alone for now. This over here is a constant. That's not going to change at all. That's always going to stay the same because there's no I in there. If there was an I in there, we'd have to change it because it would be changing when I goes from 1 to 2 to 3 and blah, blah, blah. So let's figure this out first. If we have 5 factorial times 5 over 4 factorial, and that's what this exclamation means. It means factorial. That means 5 times 4 times 3 times 2 times 1. And I'm going to use the dot instead of that x. And then that's 5 factorial. And then times 5. So times 5. All over 4 factorial. 4 times 3 times 2 times 1. And when we're dealing with multiplication, we know if it's multiplication, adding, all that, no, don't do that. Multiplication, we can. If it's one number over another number, we can take out the factors and look at them. 4 over 4 is 1, 3 over 3 is 1, 2 over 2 is 1, and 1 over 1 is 1. What we're left with is 5 times 5, and that equals 25, right? That's what we have in this bracket, 25 to the 1/2 power. I just told you what the 1/2 power is, so that means the square root of 25. And that's all I'm saying equal. We're not saying everything is equal. We're just saying this is equal. So the answer to this whole thing right here is going to be 5. So now we're left with, so yeah, just go 5. So now we're going to be left with the summation I equals 1 to 461. And minus, it's interesting that they put a minus out there because they're like, okay, whatever it is, minus. We got the minus 1 to the I times 5. Now we know 5 is this big old jumbled mess. So now let's start plugging in some of those numbers. If we got negative 1, let's do 1. Negative 1 to the 1 power times 5. Well, minus 1 to the 1 power is just going to be minus 1. Minus 1 times 5, positive 5, is going to be a minus 5. So that's when when I equals 1, the answer to this is going to be negative 5. So when I equals 1, the answer is negative 5. When I equals 2, we got negative 1 to the 2 power times 5. That equals, well, minus 1 times minus 1 is a positive 1. Minus and a minus is positive. So 1 times 5 is a positive 5. So, and we're right now what we're doing is let's forget about the minus. We're just doing this part here. And this is going to be, so now we went from 1 to 2. From at 1, we got minus 5. At 2, we got plus 5. And I'll tell you, at 3, we're going to have another minus 5. Because minus 1 times minus 1 is positive 1. But a positive 1 and a minus 1 is a negative 1. So whenever, at this point, you're going to start seeing a pattern. Whenever it's odd, we're going to have a negative number. Whenever it's even, we're going to have a positive number. So at this point, we're going to go minus 1 plus 5. Minus 5 plus 5, minus 5 plus 5, minus 5. So essentially, we know it's going to go like this 461 times. 461 is an odd number, right? Because of the 1, we know it's an odd number. So we know if it's just odd, it's minus 5. If it's even, minus 5 plus 5 is 0. 0, if it's odd, 0 minus 5, it's minus 5. Minus 5 plus 5 again, when it's even, it's going to be 0. So we're going to do that all the way up until we get to 461. If it's odd, we know it's going to be minus 5. Right? But don't ever forget, and my 5s look like an 8 sometimes, but don't ever forget what they wrote out here. There's a minus out there. So it's actually going to be minus a minus 5. So the answer to that is 5, because minus 1 times minus 5 is equal to 5. So the answer to this is 5. Interesting and kind of fun. Like I said, you just kind of look at patterns and look at things and it'll come out nice and neat. I hope I've explained a lot of good things here, and I hope to see you again next time.